programming. So these are the two important major criteria for having high level programming language. Okay, now the designers of the high level programming language, they actually they want to achieve machine independence. So I already talked about it, I need not talk about meaning of ease of programming. So with respect to the designers of computer programming language, what it means to have ease of programming. Okay, so it is more elusive than compelling goal. Ease of programming is a very elusive goal. Why does in elusive? Elusive म्हणजे मृगजळासारखं आहे ते. It's not a goal that is achievable, because ease of programming to me may be different and ease of programming to you may be different. It's not something that can be actually achievable for universal use. Okay, so I can't have a programming language that is universally acceptable as this is the most easiest programming language in the world, because it may not be a very easy language for certain kind of audience or certain kind of users. So it is always a trial and error basis on which you decide whether a language is easy to use or not, and it is always the test of programmers that decides whether a language is actually an easy language or it is not an easy language. Okay, and people actually or the programming languages actually carry out abstraction because they require to have satisfy these goals. And always any programming language you develop, these are the two goals, they contradict with each other. Can I make a language machine independent? To make the language machine independent, at times I need to include in that language some of the portion which makes that language not that easy to use, because I want to have certain abstraction that works well with a particular hardware and that also works well with the other particular hardware. So I need to make that balance between these two competing goals when I'm designing a high level programming language. Now this is the topic that we are supposed to deal with in today's lecture, and it is what is a name in general. A name is a mnemonic. Mnemonic means a string of characters. Name is merely a mnemonic, string of characters. जैसा मेरा नाम अनूप है, it's just a string of characters, 4 characters together. It associates this particular set of personality that is talking to you, a mnemonic, okay, a representation, so that I can address that I am talking to, say, Anup sir, or Anup sir is speaking. So that is why I require a name. Why I require a name? When I want to when I want to address a particular object or a thing, I should associate a name with it. Then it becomes easier for me to address that thing, and the person who is listening to or person who is reading to will also understand what it is. So that is the importance of name in general. And in programming also it is important, because in programming what we are doing, we are capturing our thoughts about computation into a programming language. Okay, so what is a name? It is a mnemonic character string used to represent something. That something means the programming object. I already told you about it. Whenever that word object comes, it is nothing but a programming entity we are going to talk about. So as far as programming is concerned, name is a string of character mnemonic that associates itself with an programming object. In most languages, they are identifiers. Names are nothing but identifier. They identify, they address a particular thing. आप नाम क्यों यूज करते हो? आपको उस चीज को आइडेंटिफाई करना होता है. So whenever you name me, you try to identify me away from other personalities that you see. So that is how the name is used for. It is used as an identifier. Mostly it is an alphanumeric, means alphabet and number combination, that we all know. It allows us to refer to a variable. So क्या क्या अलाउ करता है? नेम किस किस चीज को आइडेंटिफाई करने के लिए आपको ऑप्शन देता है या चांस देता है. So using name, I can refer to a variable, a constant, some operation like an expression, some type, and there are many programming objects to which I can refer to. I can refer to with a name to a file. I can refer to with a name to a library. I can refer with name to a module. I can refer with a name to an API or a package. So there are different things to which I can give or associate a name with. Okay, that is what this particular word, particular point tells you about. It is also allowed to realize some language abstraction. Sometimes certain language abstraction can also be associated with a name. So I may not always associate name with a programming object. I can also associate name with certain programming aspect. जैसे फंक्शन हो गया, जैसे इंटरफेस हो गया, क्लास हो गया, स्ट्रक्चर हो गया. Okay, there may not be actually a physical attribute or physical object that is a class, or that is a structure, or that is an interface, or that is a function. Okay, but this word function tells me that it belongs to this abstract concept, wherein there would be certain parameters that I provide. There will be certain set of computation that go on, and a result is computed which is sent back to me. So whenever I hear the word or the name function, it clicks to my mind that I'm talking about an abstract concept that computes based on inputs and provides me an output. So that is how we associate name to. Okay, so that is what is called as it tries to realize some language abstraction. So function is one language abstraction, class is another language abstraction, and there are many more. We can't actually count them on hands. So that is what written over here: function, structure, class, interface. All these are nothing but some abstraction which may not be directly having their role in the identifiers category of names. Okay, but they are concepts, and these concepts are also named. When I'm using a programming language, these abstract concepts need also certain name to distinguish them from the other concepts. Okay, so that is the role of name. That is why it is important in a programming language. Okay, so name is actually an identifier of anything that programmer wants to refer. कुछ भी चीज को अगर as a programmer आपको refer करना है, if it is actually a thing in a program, or like a constant, like a variable, like a type, like a certain construct, like if else or something. Okay, and it also may not be a thing in the program, but it could be a programming concept. Like, so I want to define a function, I want to define a class, there is a method inside a class, there are member variables. So all these are what? Member variables, methods, function, class. These are nothing but abstract concepts. These are conceptual names. Okay, so I associate conceptual names also when I do programming, and there are certain physical entities or physical objects to which also I associate names to. Okay, so that is all about what is a name. Okay. Okay, so this so sometimes the name also provides us to have a higher level abstraction. For instance, this name called as subroutine. Subroutine ये आपने सुना होगा या नहीं मुझे पता नहीं, because subroutine is a word that people used in way back in 1980s, 1990s. Nowadays we call it as functions, but subroutine and function, they differ a bit. So subroutine does what? It takes input and it processes it. It doesn't produces an output. So that is called as a subroutine. Subroutine क्या होता है? एक पूरा प्रोग्राम में एक छोटा ब्लॉक ऑफ कोड जो इनपुट लेगा, प्रोसेस करेगा और उसका काम खत्म हो जाएगा. सो दैट इज द वे सबरूटीन एग्जीक्यूट्स. सो सबरूटीन कंसेप्ट जो है ये एक एब्स्ट्रैक्ट कंसेप्ट है. वो किस चीज को एब्स्ट्रैक्ट करता है? वो कंट्रोल फ्लो को एब्स्ट्रैक्ट करता है. प्रोग्राम का कंट्रोल कैसे फ्लो होगा, इनपुट आएगा, उसको मैं कैसे प्रोसेस करके मेरा प्रोसेसिंग का काम कंप्लीट करूंगा, उसको एनकैप्सुलेट करता है या उसको एब्स्ट्रैक्ट करता है. दैट इज कॉल्ड, दैट इज द वे वी एब्स्ट्रैक्ट अ कंट्रोल फ्लो. सो सबरूटीन जो है वो कंट्रोल फ्लो को एब्स्ट्रैक्ट करता है. वैसे ही क्लासेस जो है, सो दीज आर एग्जांपल्स ऑफ यूजिंग नेम्स टू एब्स्ट्रैक्ट अ प्रोग्रामिंग कंसेप्ट. ओके, ये सिर्फ दो नहीं है, इससे पहले भी हमने देखा है क्लासेस, देन attributes, modules, functions, structures, classes, interfaces, modules. All these are nothing but programming abstractions. Okay, names of programming abstractions. The subroutine abstraction captures the control flow abstraction. Classes capture the data abstraction. Data abstraction का मतलब क्या है? Data को abstractly represent करना. For instance, I can create a class to represent a complex number to have two data members. One is the real part of the complex number, and the other variable will store the imaginary part of a complex number. You know that from your mathematical background that a complex number is composed of two components. One is called as real and the other one is called as imaginary. Now, if I want to represent a derived data structure that involves both these components as member variables, that will be referred to as a data abstraction. Now, for me, when I'm looking at a single unit that is represented as a complex number, that will be a complex number. But internally, it is what? For the machine, it is having two data member variables. Okay, so that is why this concept is referred to as data abstraction. So what is data abstraction? Abstracting multiple units of data as a single one. Classes is one data abstraction. Another data abstraction that you have learned about is structures, unions. One more data abstraction you will be learning in Java, that is called as interface. And the namespace, the word we use, is also a kind of data abstraction. So these are few examples of data abstractions. And in general, when we talk about use of name for abstracting a concept in programming, okay, these are the two major places where these abstractions are used: to abstract control flow and to abstract data. So कंट्रोल फ्लो को abstraction करने के लिए function ये भी एक concept है. So routines, functions, methods, they actually encapsulate or they actually abstract control flow. Classes, structures, union, interface, they abstract the data component of your code. Okay, so using classes and structures, we collect the data with logically similar meaning and create its representation and easier functionality to manipulate them. So that is how we do the data abstraction. So why we require classes or why we define classes? To combine like data together. Like data को together करने के लिए, एक जैसे data को एक साथ represent करने के लिए, we use class as an abstract representation. Okay, so this thing done. Now the concept of binding time. So what is binding? First, you need to understand binding. Binding creates an association between the name and the object to which the name is referring to. So we said that names use is what? To refer to an object. So name will always be associated with certain objects. And when I am assigning name to the object, okay, that process is referred to as binding. So creation of link or an association between a name and an object is called as binding. For instance, when you are born, okay, people start calling you with a lot of different names. But when you are Christian in English, and when जेव्हा तुमचं बारसं होतं in Marathi, okay, at that time you get one particular name associated with yourself. When you get to the school and in your class, after 1 or 2 years, you are associated with the particular name that with which your friends recognize you based on certain cracks or qualities that you have, okay, which may be same as your name with which you have Christian, or that's ज्या नावाने तुमचं बारसं झालंय, or it may be something different that obscures certain characteristics in you. So this is the binding. So various times even human beings are bound with different names, and the binding process is associating name with the object that the name refers to. That's the simple meaning of name. Now what is the binding time? The time at which the binding is created is called as binding time. Simple meaning. Binding, process of associating name with the programming object. When I do binding is referred to as binding time. So various binding time decisions can be taken up when I am using a programming language. Okay. At the time of language design, I can bound certain names to the object. At the language implementation time, I can decide to associate certain names with their, this should be program implementation. lang stands for here language. The word पूर्ण न येण्यासाठी मी तेवढा लिहिलाय. So language design, language implementation, language here it should be program implementation. So when I'm designing the language itself, the programming language itself, I associate certain names with certain things. Then when I implement the language, when I write the language code, because language is what the compiler decides what is syntactically correct in a language and what is syntactically wrong in a language. So when I write a compiler for a language, or when I write an interpreter for the language, there I decide the implementation of the language, what is correct, what is not correct. So I associate names to a lot of things, to programming entities, when I implement a programming language. And that language, that binding decision is taken at language implementation time. Okay, so certain binding decisions are taken at the language design time, certain at the language implementation time, certain at the program implementation time. Certain bindings are associated when you write the program. So user decides what he should call his variables with. The name of the variables is decided at the program writing time. कंपाइल टाइम पे एसोसिएशन किस चीज का होगा? कंपाइल टाइम पे एसोसिएशन होगा जो चीजों का नाम और उसका मेमोरी एलोकेशन होगा, वो कंपाइल टाइम पे होगा. जैसे वेरिएबल्स है, constants hai, so I can write the constants in the program, or sometimes the constant gets computed at the time of compilation. So compilation time I can associate bindings. I can associate bindings at the link time, the load time, and finally when I run the program. So program का compilation जब हो रहा है, तो अगर मैं binding करता हूँ किसी नाम को उसके object के साथ associate करता हूँ, तो that is compile time binding decision. लिंक टाइम पे जब मैं लाइब्रेरी को लिंक करता हूं मेरे कोड के साथ,